This is Professor Darif Seitz. This Java tutorial introduces creating your own class. The class used here as an example is a binary string class. It's a simple concept. It's a string that contains zeros and ones, a binary number in a string. The class statement is here. It's public class. Next, we have the data members of the class. They're all private. One's a constant. It's NAB, and its value is not a binary number string. There's a similar thing with other numbers, like not a number. This is not a binary number, NAB. The internal representation here is the binary string data member. It's a string. Of course, this is all private, and users of the class don't need to know anything about how it's implemented. They're just going to be using the public interface that we'll look at next. There's a private error code with 3 values, 0 being that there's no error at all in this binary string, and 1 and 2, the string is limited to 50 bits. You can't have more than that, and they have to be zeros and ones. First, we have our constructor. It has the same name as the class, and it's a constructor that takes a string as a parameter. When we get this, we initialize our internal binary string with that parameter, and then we call a validate function in this class that's private. It's going to validate at the time of construction whether it's valid or not. To keep things simple here, we're not throwing any exceptions. If you don't know about exceptions, don't worry about that yet. But we do a validation, and the validation will set the error code, and then we check on the error code. If the error code is not 0, that means there was an error. We change the string to be the NAB. Whenever you create a class, you should provide an equals function, which overrides the equals function in the object, which is the base class of all classes. Here's the pattern that you follow. You have the same signature. You check first whether what's being passed in is another object called other here that you're going to compare to. If other is not an instance of our class binary string, then it can't be equal. We return false. Otherwise, we explicitly typecast other to a binary string called bsOther, and then we check. We look at our binary string, which is a string here, the internal member, whether it's equals, that's the string class equals function, to the bsOthers binary string, and if that's not true, we return false. Otherwise, we return true. That's the standard pattern for the equals function. We only had one data member we needed to check. For other classes, you would have to have more checks at the different primitive types and object type members in your class. We have a getter function known as an accessor. We get the error code. It's public. Then we have a public 2-decimal string. It will take and convert it to a string, but it's the decimal version of the binary number. So first we check when they call that to make sure that we are valid. We're not an NAB, because if we're an NAB, we're just going to return NAB. We're not going to try to convert something that's not even a valid binary string. And then we go down to the logic here where we convert the string to an actual decimal string, looping through it and picking out characters, and the ones that are a 1, we're building up base 2, powers of 2 into this number, and then we decrement the power as we're going from left to right, because the binary representation, as we'll see in a minute, that's how it works. And then finally we take that number and convert it to a string and return it. Also, every class that you provide, you should consider having a toString function which overrides the toString and object. We're simply returning our internal string here as that function. Here is our private validate function where we go through and make sure that it's not bigger than 50, that it's not an empty string, and that it does contain all zeros and ones. Now we're going to switch over to a client class here that uses this binary string class, and we use it to test it out. We have some test values we're going to be recommending here, but we'll probably just make them up as we go. But this test class called binary to decimal client, it has a scanner. At one point it will get input from the user. It has the main function, so the application will start here, and the first thing the main does is instantiate this class itself that it's in and calls the object UI for user interface, and then the user interface is going to run a general function that's in it and then run a conversions function that's in it. The general function down here is going to create some binary strings, a binary 1, 2, 3, and 4 with these inputs, the ABCD, 1001, 1001, and this one, and then do some equals comparison to see if binary 1 is equal to itself, if 2 is equal to 3, do some equals comparisons exercising the equals function. Then the conversions function in here is going to go into a while loop on true and ask the user to enter a binary number, and each number that's entered, and also they can end it by entering n. It's going to take that number here and get it with the scanner next line, and if it's not end, then we're going to use the input that we receive from the user to instantiate a binary string and check the error code right away to make sure that it's good. If the error code is not 0, we have an error. We're going to call a function called display error with the error code, which displays the appropriate error message in a switch statement on the error code. And then we're going to call continue, which goes back up to the while loop to continue the loop, because that was a bad input and the user has to try again. Otherwise, if we got a good input, we're going to print out the conversion, calling the 2 decimal string function. Let's go ahead now and run this client program. And we'll move this window into where we can see it here. The general functions, binary 1, which was ABCD, when we tried to instantiate it, it got the NAB, not a binary, and that actually was this string, as you recall. Here's binary 2, 3, and 4. They're two string functions. And comparing binary 1 to itself is equal. Binary 2 and 3 are equal, and 3 and 4 are not equal. Now we're down here where it says enter a binary number. If we don't enter anything, just hit the enter key. It says, well, that's not valid, didn't have zeros and ones. If we enter ABC, it says that's not valid either, didn't have zeros and ones. Alright, so let's enter 1, 0, 0, 0, hit enter. It returns 8, because in binary this first position is the units, that's the 2's, that's the 4's, and that's the 8's. In base 10 it goes by powers of 10. In binary it goes powers of 2. So it's the first, the 2's, the 4's, and the 8. So that 1 is in the 8's position, we get an 8. If we do, let's add 1 to that, and we should get a 9. We do. Let's experiment with some other numbers. if I just put a bunch of ones in here, that should be larger because we have higher powers of 2, and it is. It's up in the 16,000s in decimal. Let's try just 4 ones. See what that gives us. That's 15 because that's a 8, a 4, that's 12, a 2, that's 14, and a 1 makes 15. So we see our class appears to be working as we thought it would. Let's try one more input. If we do 1, 2, 3, 4, and then a space, and then some more binary things, now we have a space in it. It's going to complain about that because it can only have zeros and ones, and it gets the whole line whatever you enter there. Let's put a 0. That works. A 1. That works. Okay, to end it, we enter end. And now we're back in our source code. Going back to our class, our original class that we're focusing on here. So you see this is an example of how you can create your own classes to do certain things that you want them to do. And there's unique functions for the class and unique data for the class, but there's also some expected things that you should provide. It's expected that you provide constructors, obviously, for your class, a toString function, an equals function as well. That's just being a good object citizen so that people can use your class in expected ways. So this should kind of give you some ideas then about how you can start creating your own classes.